What you're looking at here is basically the change of variable formula. How do you convert a double integral in terms of x and y into a double integral using u and v? And essentially, you'll have a formula that says, you know, what x is in terms of u and v and what y is in terms of u and v.
And that's what they call the Jacobian transformation, right?
Yes. Yes, it is.
Okay.
And so,
okay, I just wanted to make sure because the homework says do the Jacobian transformation. I just wanted to make sure my understanding of it was right.
Your understanding is correct. So basically, you turn all your x's and y's into u's and v's. You find this guy called the Jacobian, which is, you know, major, takeaway minor. And then your integral then becomes u and v. There is one other transformation. The region R is in terms of x and y. You have to convert that, we call it its image, into a new region S using u and v. And that doesn't seem to be a problem at the start. It becomes more problematic later on in the questions. So basically, this is the method for changing variables. So you start with an x, y, and you end up with an integral with u and v. And the integral in x and y, the original, will be very difficult to do, if not impossible, if you left it that way. And that's why we changed it into u and v. Same reason you would do it in calc too, right? You don't like the integral of x e to the x squared. Horrible thing to try and do. But if you do a u sub on it, it just simply becomes a half e to the u. It becomes much easier to do. And let's get started. So, if I give you who x and y are in terms of u and v, let's just do some practice finding the Jacobian. This one is a version of question 2. And x is u squared plus uv, and y happens to be 2u and v squared, which is fine. We're just being asked to find this fella. You do it with u, you do x with v, you do y with u, and you do y with v. Okay, it's early in the morning, so watch out for mistakes. If you do into differentiation with u, you get a 2u plus v here. If you do this with respect to v, you just get a u. If you move on to the y's now, if you do that with respect to a u, you get 2v squared. If you do it with respect to a v, you get 4uv. Looks okay? Right. So, major diagonal. 4uv times this guy, major diagonal. Take away minor diagonal. This times this gets me 8u squared v plus 4uv squared. Take away 2uv squared. So it looks like I'm going to get 8u squared v plus 2u v squared. I'll leave it like that. It's as good as anything. I guess I could factor it out if I want to make it look pretty. Are we comfortable with just basically you tell me who this guy is, and I can find a Jacobian? You feel comfortable with that? Because that's pretty much the bit that's going to go there. Now, there are some restrictions. They're really just more annoyances than anything else. And this Jacobian guy has its own absolute value around it. Do you see that? And the reason that's there is that technically the Jacobian must be positive. Now, if it's an expression, we have to just assume that it's positive. But sometimes, the Jacobian is a number. And sometimes that number is negative. And when that happens, your Jacobian, or at least the absolute value of it, will be 11. But be careful about what you're being asked for. If you're only being asked for that, the answer is still negative 11. If you're using it in a bigger question, in other words, you're using it to get an integral, remember to turn it into 11, right? So in the early questions, they just want to know the Jacobian, which means if it's plus number or negative number, that's what you get. In the second half of the questions where you actually start finding integrals, this fella here might occasionally be a negative number, so you remember to convert it to plus 11. On the
So
other
if
hand,
you put it into the integral form, you want to take the absolute value of it and put it into the integral rather than leaving it negative.
Yes, and if the expression, if the Jacobian is an expression, there's not an awful lot of advantage to doing that to it because it really doesn't help the process. So we assume that it's positive. So when it's an expression, you don't really change it. Now that I've said that, the only time that that might actually not be true is, can you imagine a Jacobian where I ended up with that as the answer? Now it is an expression. Remember, the Jacobian has to be positive. So in this one exception, because I've just thought of it, so that means it probably won't happen. But if it did happen, wouldn't you use that guy?
Yes.
I mean, the absolute value, right? But to be honest, I doubt very much, unless the world is against me, that you're ever going to get that. But if something comes into my head that I know is not true, then if I think of an exception, I'll tell you. And I just thought of an exception, which, as I said, probably won't happen, so it won't be a biggie. Doing a scan to see if there's really anything I need to worry about. I guess, nah. Oh, here's one with a number, just to show you you can get numbers. So version of 5. X is 2u plus 8v. Y is going to be 3u plus 4v. Don't do that. There we go. So the Jacobian. I mean, the notation that they use for Jacobian, does it not imply there's some differentiation going on? Doesn't it also imply that it's a partial differentiation that's going on? And lastly, doesn't it kind of imply that there are going to be X's and Y's on the top and you're going to be differentiating with U and V in the bottom? So that notation is quite useful, isn't it, to give you an idea of what goes where? Now, back to this question. If you do this guy, you get 2. If you do this guy, you get 8. If you do this guy, you get 3. If you do this guy, you get 4. Major diagonal, subtract minor diagonal. 8 take away 24, you're going to get a negative 16. And for that question, the answer is negative 16. Okay, because it's not involved in an integral yet. When I do a question that involves this as an integral, then I will need to turn that into a 16 when I plug it in here. I feel comfortable, I hope you do, about if I give you one of these guys, can you find that guy? Can we call that good? Right. Okay, so let's move on. Yeah, thank you. Let's move on to actually applications. In fact, let's start with question 7. We're being asked to find a double integral over some region R of the function 10y squared dA. I just realized that should be dA Don't you use dv when it's a triple integral? So it's really an integral over an area. So this fella, and what we are told that the region R is bounded by xy is 6, xy is 7, xy squared is 6, and xy squared is 7. We're also given that u is equal to xy and that v is equal to xy squared. So we're pretty much given everything on a plate here. Can we pretend for a minute that they only told you the region R was bounded by all these curves? You would have to create your own, basically your own change in variable, right? Your own U's and V's. And you might think, how will I do that? Well, xy is 6 and 7. Doesn't that naturally make, if you make u xy, won't that just turn into u goes from 6 to u goes to 7? And do you see how xy squared is 6 and xy squared is 7? If you make that the other variable, doesn't that make v go to 6 and v go to 7? Do you see that in here, the description of the region R, there are clues to who you're going to make your u and your v? We call it that. Now, we need a number of pieces to get our answer. We need to convert this function, 10y squared, into u's and v's. So I'm going to just put that as a placeholder because I don't know the answer to that. Then it's going to be the Jacobian and du dv. Well, I do have a change in variable, but it's not really the way I need it to be, is it? I want x to be a function of u and v, and I want y to be a function of u and v. So this is where the algebra kicks in. If u is equal to xy and v equals xy squared, try and solve for x and then y, or for y and then x, whichever one looks the easiest. I'll call this equation 1 and I'll call this equation 2. Have you got any suggestions?
Subtract them? Or no, divide by each other?
Oh, I like divide. How are you going to divide them then? 1 divided by 2.
V on top, 2 divided by 1.
Okay, so 2 divided by 1 gives you v over u, gives you xy squared over xy. So you get v over u is equal to y. You have just found one of your 2 problems. In fact, haven't you just found that one? Isn't y v over u? Okay, how are you going to get x then? I guess you could guess until you
Plug
got
in
lucky.
y into u into 1. Plug in what you have for y into equation 1.
So substitute the fact that y equals uv into, nothing wrong with equation 1. Could have plugged it into equation 2.
With a little more effort.
Yeah, so it don't matter. If you can find one, isn't getting the other one going to be easy? Because you're just going to substitute it in, right? So the quest here is to figure out how to get either the x or the y. In this case, then, let's see what we get. We have a u equals xy, a u equals oops, x times v over u. What does that give me? U squared is xv. That means x is u over v. And why do we need those darn things? Because don't we have to find that darn thing? And the only way I can find the Jacobian is if I know what x and y are in terms of u and v. So do you see that we've now got an extra level of complexity here, where we have to try and take some information that's written in this format and use it to get the information in x's and y's. It's a little bit different. Are we cool with what we just did there to get that information?
Yes.
Okay, so now I can do my Jacobian. I'm not going to write that formula down. It's getting boring. Right, this guy with u gives me 2u over v. This guy with v gets me negative u squared over v squared. This guy with u gets me v. And this guy with v gets me negative v over u squared. Does that look good? Now, major diagonal 2u over v times v over u squared. Take away minor diagonal.
Professor,
Yes.
for the y, shouldn't that be flipped? For the y, the dy over du, shouldn't that be minus v over u squared?
Oh, you mean this one here?
Yeah, shouldn't it be flipped?
Let's check it. Differentiate this with u. You get that? Differentiate this with v. Is that what you're saying?
Yes.
Check it out.
Yes.
Differentiate that with u, you get negative v squared over u squared. Differentiate that with v, you get 1 over u. Right, well cut. So it's going to be 2u over v times 1 over u. Take away negative u squared over v squared times negative v squared over u squared. Cancel, 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 cancel. Looks like I get 2 over v here. God, there are negatives everywhere. So it's take away. Cancel, cancel, cancel. Oh, I make the Jacobian. That guy. Does that guy look good? This times this, the u's cancel. And you get 2 over v. This times this, everybody cancels. There's a negative, and one more negative, so it's a negative 1. If we are good on that, then we're going to move on. If it's not right, you tell me. Don't help me.
Shouldn't the dy over du be negative v over u squared and not negative v squared over u squared?
Are you telling me I don't know how to do it? Do you know what I should have done? I should have just stuck in dx by du, and it would have saved me a whole load of grief. Let's find out. It's not that hard to do. I'm making a meal of it. But I have learnt one lesson. I am no good at missing this thing. I need to put it in. So I'll find out which, if any of these, I did right. If you do this guy with respect to u, the top gets you 2u over v. If you do this guy with respect to v, basically you're going to multiply by power. And you're going to get that guy, which means I got that one right. If you then do dy by du, so focus on this one. If you do this with respect to u, you get that guy. If you do this guy with respect to v, you get that guy, which means, yes.
I think the dy du, the v squared should not be in the numerator. I think it should just be v, right? Because y is, yeah.
Yeah.
Yes, exactly.
There you go.
There we go.
So, yeah. So now
So
yeah.
we are finally, after 4 mistakes,
Yeah, that's better.
this is good. Okay, cancel, 2 over v, a negative, cancel, 1 over v. Check that out. Cancel, 2 over v, cancel, 1 over v. I get 1 over v. Do we agree?
Yes.
Perfect. Okay, so after a little hiccup or a lot of hiccups, we finally got to the point where we need to put all the pieces together. So what is going to happen here is that we're going to do a u going from 6 to 7, and the v is going to also go from 6 to 7, and that comes from here. I have a 10y squared, which is going to become 10 times y squared. Going to have a Jacobian, which is this fella. And now we can do a du, a dv. So the original integral, which was this guy, has now become this fella. Okay, tidy it up a little bit. V equals 6 to v equals 7. U equals 6 to u equals 7. That's going to be a v squared. That's going to be a u squared. It's going to cancel out with one of these guys. So it looks like I'm going to have a 10v over u squared du dv. Does that look good? A yes or a thumbs up would help.
Yes.
We are good to go. If you look at this, would you agree it's variables separable? So I'll give the 10v to this one. And I will give the 1 over u squared to this one. This guy is 5v squared, evaluated at 6 and at 7. And this guy, well, if you call it u to the -2 and you add 1 to its power, you get -1 over u. And you're going to evaluate it at 6 and at 7. And this guy is going to be 5 times 7 squared, take away 5 times 6 squared. And this guy is going to be -1 over 7 plus 1 over 6. And I'm just going to dot that. You'll get some ugly answer, but it'll be an answer.
If you called that, oh, because you're adding 1 to the power, never mind.
We good?
I was thinking because if you move, yeah.
Yeah. But I think today it's a good idea to query everything I write. And hopefully the next one should go smoother, but there are no guarantees. If it hadn't been the fact that the Jacobian was a pain in the butt for my brain, I think it would have went a lot smoother. So that was what question, that was question 10, wasn't it? Yes. This is a version of question 8. We have this fella, 8 lots of x take away 6y over 6x take away y. Essentially dA will be dx dy. And what do we know about R? R is the region that you get when you bound the shape by these lines. Now we have to choose the UV sum. So we have to choose the change in variable. And we're typically going to do it as u as a function of x and y, and then v as a function of x and y. And once we've got that, we have all this algebra stuff that's going to come after it. There is a very, very big clue here, isn't there? If you make u x take away 6y, and you make v 6x take away y, won't this turn into a u from 0 to 4 and a v from 8 to 9? So if you're thinking, why did I pick these two guys? I picked them because of the boundary of R. Are you comfortable about how you can use that clue to choose your substitutions?
But it would work either way, just out of curiosity.
I could call this U and that V and it would work fine. And all that would happen is the labels would change. It wouldn't really change anything important. Now, unfortunately, that's not the guys I need. Aren't the guys I need x equals a function of U and V and y equals a function of U and V, because I need them to be in that form so I can get my Jacobian. But let's fill this fella in. 8x minus 6y is U over 6 minus thingy-bob is V. Would you agree that this becomes that? Is it not another clue that we've picked the right U and V? That this turns into nice. So what have I got left? I have Jacobian. Du dv. So once I figured that guy out, won't this be the integral that we're going to use? And this is going to have to be in terms of U and V, or at least a number, right? So I'm going to show you two different approaches to this special case. Equation 1, U equals x take away 6y. Equation 2, V equals 6x take away y. And remember what our goal here is. I want to solve for x and then y, or I want to solve for y, then x. Dividing is not a good idea here. It was in the other question, but not this time. Has anybody got strategy for fixing this? And the clue here is, think of what you did away back in Math 94 and 99 when you tried to solve a system of equations, because I'm going to use very similar math to do this one.
Are we going to multiply or
Yeah.
one of them?
Yeah. Do you, any suggestion which one you want to do? You can do different versions, they all work, but any one that does work would be nice.
Well, multiplying 1 by -6 would cancel the x's.
Okay. So what I would get if I did that would be -6u equals -6x plus 36y. I can leave v alone then. And then if we add the equations together, we get v take away 6u is equal to 35y. And that makes y 1/35th v take away 6/35ths u, and that is an ugly answer, but it is correct. Now I know what y is. how will I figure out what x is?
Just plug it back in.
So I could substitute what I know about y,
Damn this. Wow. Okay.
and I can substitute it into, and does it really matter which one I substitute it into 1 or to 2? Will it work?
Yeah, it'll work either
It'll
way.
work. Does either of them look easier or harder than the other? Because if it does, that's probably the one I should use. My gut feeling is 1. So if you think 2 is better, go ahead and try it. So I have this. 6 lots of this is 635 V's. 6 lots of this are plus 3635 U's. If you add that to both sides and you take that away from both sides, you get 6/35 V. That kills off most of that, but there's still a negative 1/35 U left behind. There is my X. And so I can now do the Jacobian. The only, and it's not much, oops, the only good thing about this is that at least these are easy to differentiate. Okay, if you do this guy here with respect to U, you get negative
Wouldn't it
1.
just be, oh, it is regular U. It almost looks like a U squared from your equal symbol.
Do this guy, you get a 6/35. Do this guy with U, you get a negative 6/35. Do this guy, you get a 1/35. Going this way, you get negative 1/35 squared. Take away is like add, so you're going to add 36/35 squared. That gets you 35/35 squared. That gets you 1/35. You have now found your Jacobian. He's 1/35. Now, I said there's 2 ways to do this right at the start. This way is the way that you tackle all Jacobians, regardless of what they're like. So that's how you would kind of tackle the U, X equals UV or whatever it might be. However, there is a special shortcut that you can use whenever U and V are linear expressions. So if U is 2x plus y and V is 4x minus 7y, right? If they look like that, there is a really cool shortcut for getting the Jacobian. And this is how it works. I know that the one that we want to get is that one, right? That's what we're after. And we already know the answer, right? We did it the hard way. It's 1/35. This is the shortcut. I'm going to do this Jacobian. Now, you notice that X's and Y's and U's and V's are switched places. I'm going to get that guy. And let's see what this fella looks like. Well, you get a 1, you get a negative 6, you get a 6, you get a negative 1. Major diagonal negative 1, take away, 2 takeaways, 36. You get 35. How does that help me get this? Well, if you are linear, the reciprocal of this is the guy you were looking for. Now, would you agree that's smoother and easier to do?
Agreed.
So if it's linear, and I'm putting that caveat in. This technique will work. Right? If it is linear, you can do this little, it's not, there are valid reasons why it works. One of the major reasons is that it's a number, and that works really well. It doesn't work if you had, you know, x squared and u squared and v squared or anything like that. And the reason it doesn't work, your answer's in the wrong variables. Okay, so back to our little question. We now have, it's from v equals 8 to 9. Oops, excuse me. It's u equals 0 to 4. It's 8u over v. The Jacobian is 1/35th. And then we're going to do a du dv. And that can split. So it's going to be 8 9s. I'm going to give everybody here. Too late now. I'll give everybody to the v. And I'll just give the u that guy. Actually, can I just pull that totally outside? In which case, it's just a 1 over v and a u. So we have 8/35ths, the natural log, and a half u squared. From 0 to 4. I should actually be able to do this. 8/35ths. Log of 9, take away the log of 8. 16 gets you 8. So I guess it's 64/35ths. The log of 9/8. Are we good? Any questions, apart from the fact I may have screwed up some algebra? I think I'm getting a little bit more awake. Are we good? Moving on.
About that.
Say again?
I feel okay about that. Yeah.
Right. We got time. That was 8. Yeah, we got time. I'm not going to do the next question all the way to the end, because I want to get as much done in what little time we've got. So this is 9. And we're going to do a double integral over some region R. 5 x plus y, e to the power of x squared take away y squared dA. And the region R is described in this format. Okay, tell me who you should pick for u and v here.
So they both have 0 bounds. So is it just kind of up to us?
Yeah. So who do you want u and who do you want v?
X minus y for u.
And v?
X plus y for v.
Would you agree that if you know boundaries and they have this shape to them, that it's screaming out, make u x minus y, and this pair is screaming out, making that? Because if you do that, won't your integral, this fella up here, when you convert it into u's and v's, simply be u from 0 to 3, and v goes from 0 to 10. Okay, now 5 is 5. X plus y should be u. Oh God, what's this? Well, x squared minus y squared is not as bad as it seems. because it has to be converted into U's and V's. Agreed?
Would it be U times V?
Yeah, because isn't x squared minus y squared just this guy times that guy? So everything's turning into U's and V's, right? I've got a Jacobian, which I'll be putting in here. And finish with, oops, in this case, dv du. Okay, don't we have a nice linear U and V? Which means, can't we do the shortcut for the Jacobian? Agree? So in the shortcut for the Jacobian, we actually find this fella and then take its reciprocal. So do it with x, do it with y. Do v with x and do v with y. See, I've learnt my mistake. Do this with x, do this with y. Do this with x, do this with y. Major diagonal 1, take away a negative is add 1, you get 2. That makes my guy, the one I really need, a half. And that makes this fella here, right? Essentially, just a half. Now, what you're left with is 5 over 2 u e to the power of uv, and you can do dv first, and then you can do a du, and the variables are not separable, so you're just going to have to do it the good old-fashioned way. Actually, I think I got lucky here. I think v would be easier to do first than u. And that's the end of that question. Anything about that one? Are you comfortable about how you pick the u and the v when you're given the choice? Here, pick a suitable substitution, right? How it was u and how it was v. Okay, then I shall move on. This is question 10. Doing a double integral of 9x squared. We're doing it over region R. And region R, oh. Yeah, I'll do it. Region R is an ellipse. And you do not actually pick the u and the v, which is what was screwing my brain up, because I was figuring out how we would do it.
So they just tell us.
Yeah, which makes life easy. So, and it's nice that they told us it in the format that I want it to find the Jacobian, right? They've told me in terms of x equals and y equals, which is exactly what it needs to be, right? So I need to figure out what R looks like. So that's the difference here. Well, if this is, you imagine it, an ellipse in XY space, let's see what it looks like in UV space. Well, just replace the X by 4U and replace the Y by 5V. And you get 400 U squared plus 400 V squared equals 400, which makes it a circle of radius 1 in UV space. So if I want to describe a circle, wouldn't it be polar? Wouldn't that be the easiest way to describe a region in space in polar? So we are going to be doing an integral over region S. 9x squared becomes 9 lots of 4u squared. And we're going to do a Jacobian. Now, I probably should have done this guy earlier, so I'm going to do it now. That mess in there. Is that fella? Right. Jacobian with Y. Jacobian with V. That guy. That guy. Okay, what do you get? You don't get anything very interesting. You get 4 and 0. You get 0 and 5. So the answer you get is 20. Okay. So that is a 20. So I'm going to do a double integral over a circle of radius 1 of 20. That's 20. A 9 and that guy. So what do I have? I have a 9. I have a 16 and I have a 20. So I have 2880 u squared du dv. Okay, so I have to figure out how to integrate a circle with respect to u and v. Well, wouldn't that be polar? So technically speaking, I'm doing 2 changing variables, aren't I? So what would that become? Well, it would become 2880, the integral of u, which is r squared cos squared theta, r dr d theta. R would go from 0 to 1 because it's a circle, and theta would go 0 to 2 pi. So I had of 2880, the integral from 0 to 2 pi of r cubed cos squared theta dr d theta. And isn't this guy separable? So 2880, the integral from 0 to 2 pi of a cos squared, and the integral from 0 to 1 of an r cubed. And that's going to have to be a dot, dot, dot. Okay. We did not get to question 11. But in question 11, they tell you who the substitution is, so it's not such a big deal. And in question 12, 13, and then 14, is that pushing it? I think that's pushing it. Okay, we are going to be stopping this homework at question 10. So I'll remove the others and we'll put them in as stuff we can do after the test. So your homework is going to be finished at question 10, which is essentially the one I've just done here.